Hello friends, welcome to AMT, Automotive Embedded Technologies. Today we are going to discuss about the interesting and important technology of the automotive industry, that is cybersecurity ISO 21434. And today we will discuss more insights of the cybersecurity standard, what kind of cybersecurity risks are involved in the automotive industry, what kind of threats are possible, and what kind of mitigation techniques that we take in terms of project development, product development, software development, and etc. So we'll go to further slides for more details. So we just go with an overview, the basics, what is meant by cybersecurity, what is the importance in automotive industry, what kind of attack paths, scenarios, and different kind of threats that are possible in a car, and what kind of risk points are possible in a vehicle, that where the vehicle interfaces, either hardware or software or components, whatever it is, can be affected by the cybersecurity. These are called as risk points. And how do we achieve the cybersecurity in reality? First of all, we need to understand what is cybersecurity. So cybersecurity basically refers to the techniques what to be followed to protect the integrity of the networks, means data integrity of the networks. So in a network, there is huge amount of data has been transmitted and received, and there are several client and server operations has been happened, and how protection will be provided for the integrity of these networks. Also, what kind of damages can happen to the system or network or the environment, and how the access, unauthorized or authorized access, um, means, and what is the main content of this authorization, are the main points where the cybersecurity basically refers to. And coming to ISO 21434 cybersecurity definition, talks about more assets, the reference points where the attacker can attack a system, whether it can be a hardware perspective, software perspective, network perspective, and connectivity perspective, etc. And how these assets are protected against several threats, which may be belongs to an electrical and electronic components of the vehicles, and how the functions will be protected in the real world, and what are the main contents involved here is the most of the information that is present in ISO 21434, I would say. Coming to next, importance of cybersecurity. What kind of innovations in the modern vehicles has been happened towards electrical and electronic systems, autonomous vehicles, connected driving, data sharing between vehicles like V2V communication, also the connectivity between vehicles and cloud and user. So here we just see a small glance from 1900 to 2000. If you see, we have several stages where we don't have not even a single electronic in 1900s, and in 2000 we have a lot of electronics, sensors, actuators, intelligence, more connectivity, and more autonomous drivings are involved. So for this reason, we have a lot of data shared between several units by wired communication, wireless communication, and more connectivity to the private users, which is more sensitive. And definitely we need a security here. A threat can be introduced in the system by the private users, or by manipulating the cloud data which is connected to the vehicle, or by the components, manipulating the components of the vehicle itself. So this is the main reason that why we need cybersecurity. in this automotive industry. And yeah, coming to security risk points in a car, we have several security risk points in a car that we can see as overall. We have infotainment, telematics, onboard diagnostics, and several issues like airbag control unit, steering control unit, braking unit, engine transmission, etc. And we have several interfaces like USB, Wi-Fi, LTE, Bluetooth, remote key, where we have either wire or wired connection directly connected between the private devices and the vehicle. And if we see onboard diagnostics, this is an external tool that really can get the diagnostic data of a vehicle using also an open source tools or a specific tools used provided by the OEM. And this data can be accessed, erased, and create malicious threats inside the car. Is really there is a possibility here. So these are the main risk points in a car, I would say. And coming to next slide, what are the threats to the system? What are the main threats to the system in terms of vehicle? So we have here the connectivity, e-mobility services, and different kind of hazards that cyber attacks can happen. Here, if you see physical attacks, sensor confusion, like exchanging the sensors which are working properly with the sensors corrupted by the attacker and can provide malicious data to the system, and then algorithms may go wrong, calculation may go wrong, and at the end it will affect the vehicle dynamics, maybe altering the speed, altering the air conditioning system, altering the seat heating, and altering the lighting and whatsoever, which will disturb the environment as well as vehicle user. And coming to other attacks, or most of the attacks, if we see, they are relevant to the password attacks as well as uh, application vulnerabilities, data leakage between vehicle and cloud, data corruption between the private devices of the user and the vehicle. So there are a lot of threats to the system if we see here from backend in terms of vehicle components, in terms of user devices. And we go to the next slide for the further details. And how do we achieve this cybersecurity in reality? What are the main contents that must be followed to achieve the cybersecurity in reality? First of all, we need to define the goals for the cybersecurity, what we need to achieve. Even it can be a single concept, single asset. And what are organizational level measures that are taken care? What are secure engineering methods that we need to follow? And what kind of security concepts are present layered? And what kind of vehicle architecture that we need to choose for a secured um, whole vehicle? We go with the details in further slides one by one. Coming to cyber security goals, the main goals of cyber security are authenticity, integrity, confidentiality. Authenticity is the trustworthy of the data exchange between point A and point B. Authentication of the data between point A and point B. Coming to integrity, the data which has been transmitted in between node A and node B, how much this data has been secured. Coming to confidentiality, before we share data from point A to point B, how this data has been encrypted and how successfully this data has been decrypted at the node B. So these are the main important points that need to be followed to define the goals of cybersecurity: authenticity, integrity, confidentiality. So these are the main three aspects of cybersecurity ISO 21434, I would say. Coming to next slide, organization. So what are and all organizational um, 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 process that we need to follow in organization? For example, responsibilities of the cyber security, and do we have a separate organization structure? And who is a cybersecurity manager, who is a cybersecurity engineer, who is a tester, and coming to planning how the cybersecurity development of a system or software has been planning. And for example, if you have several projects that are reused and are tailored to the next projects, and how this tailoring is happening, what kind of risks are present during this tailoring, and what are the components that can be out of context when you do this tailoring. May not be 100% of the project can be taken from one OEM to other OEM project. There will be definitely customization of several application or software or hardware components involved, and how these are taken care when you reuse a project, and how the cybersecurity cases are being defined. Cybersecurity case in the sense it lists all kind of activities that has been done so far in the cybersecurity process, like risk assessment, the TARA, defining test cases, implementation of software components to achieve the cybersecurity concepts defined, and software testing, system testing, and how these all are done has been documented according to the process based in cybersecurity case. Cybersecurity assessment. So what kind of assessment that we can do based on the whole study what we have done so far to the project, and what kind of assurance level, cybersecurity assurance levels can be given, either 1, 2, 3, or 5, etc. And after the product or software development, how we release, and after releasing these software or hardware sections, and how the post development activities are ongoing during production or during maintenance and so on. So this is whole organization level of point that we have to work on apart from the technical aspects of the real product. Coming to site, we have secure engineering. What is secure engineering? So here I just go through brief for each module. Here we have an asset defined, threats, risk assessment. So what is an asset? Asset is a basic reference to attacker to take the opportunity to make this interface as a malicious interface and provide a wrong inputs to the system. For example, let us take a CAN protocol is an asset, an interface, I would say. So the threats and risk assessment. For example, you said threats. What kind of threats can be followed? Like if you know dumping of a lot of unused data or manipulating the data what has been sent over the bus. And with this data, what kind of risk can be possible? We need to perform a risk assessment here. And this is the main topic. TARA is systematic TARA is the main topic of the cyber security, where we do threat analysis and we perform assessment and risk. So this is called threat analysis and risk assessment. Maybe we can discuss this topic is very sensitive in a separate video in upcoming videos. How TARA has been performed and what is the inputs and what are the calculations we do and what will be the outcome and what are the references followed. This we discuss in separate video. And coming to this, after defining an asset and threat, finding an assessment for a risk, how do we achieve? Before we think how do we achieve, we need to provide some goals. What should I achieve from this risk or threat? How can I protect my system? So we need to define the security goals for this, and then define the requirements, basic requirements, and define a concept for this. So security concept is a starting point that where we are thinking about we have an asset, we have a threat, we have the risk assessment, and how do we mitigate this? The mitigation is action is actually started from defining the security concept. For example, for CAN protocol, I would say using secured onboard communication on CAN protocol can provide authenticity and integrity of the data when you're transmitting a message from CAN A to CAN B nodes, where we perform a lot of encryption and decryption activities. We use freshness counters, we use timing values, and etc. I'm coming to implementation. What kind of software development methods that we followed? Like what kind of keys, what kind of encryption or decryption algorithms we use, like RSA 128 or 256, and what else of other AUTOSAR based software components or stack as crypto stack has been involved here for providing the security of the data. And coming to verification, so after all we do implementation. How do we verify this? What kind of tools we used? How many test cases we have written? For example, you have fudge testing, penetration testing, and there are several kinds of testing that can be used to detect whatever the implementation that we did really achieved. Are we really getting the real protection by the implementation from a malware attack or not? We need to check. Also, validation. If we define a concept, we need to validate if the concept is really protecting the uh, really um, achieving the secrecy of the system that what we developed, and are we really mitigating the risks here from the threats. And coming to the cybersecurity case assessment and compliance, this is what I just spoke in previous slide. We do assessment. For example, we found an asset, we found threat, we found a risk assessment, and we define goals, we define a concept, we have implemented, we have verified, validated, and who will assess this? Whatever the process has been followed is effectively implemented or not, process point of view. And after this, during production, during operation, during servicing, how this is maintained as it is. For example, I have a software and I have an ECU and I have an SOP and I have delivered a product to the customer. And during maintenance, I got several issues. And there I could find there is the involvement of threat. And again, if there is a threat, if there is a asset associated with the threat, again we have to come back for this level, do the risk assessment and check the goals and define a security concept. So this is a continuous cycle, I would say, is required whenever there is a new threat. Of course, we will go with our existing knowledge of possible threats, but we may also don't know that what are the new threats that can happen once you deliver the product to the market. So this is a constant process that I would say. Coming to next slide, there are several concepts in several layers defined to achieve this. For example, secure communication, intruder detection mechanisms, access control, key management, firewalls, and synchronization of the time, authenticity of the communication, integrity of the data by using freshness of the communication, confidentiality, and different kind of keys that we use, symmetric and asymmetric keys, and how we store in the system, whether we store in microcontroller storage or external storage, and how they are being protected, and how we can access them when we use some certain kind of mechanisms called secure boot and secure flashing, and what kind of crypto algorithms has been used, and what kind of HTS has been used. So these are defined based on platform and in vehicle, external to the vehicle communication or gateways. So these are the security concepts on top level that we need to address when we define a security concept for an asset or a threat or a risk that we found. To next, secured vehicle architecture. So it's just an overview as a pictorial representation of the properties that we use in real cybersecurity and how do we achieve them in a vehicle level. So in a vehicle we have several sensors, several electronic control units, several sensors, several electronic control units, several gateways, and several user devices, all which are connected to the external world. Also for the connectivity to the cloud, also the connectivity to the entertainment units in the car, also for the diagnostic interfaces. So if we see for each block, we can see as a common the blocks what we see, most of them which are in car or in connected in vehicle has minimum of a key, a secure flasher, secure booting mechanism, and an hardware security module where we have the indirect connectivity with the vehicle keys. Vehicle keys nothing but it's not a key fob, but the digital keys, kind of a piece of code, piece of hex values that has been used during flashing, during booting, and extracted from hardware security module, which might be connected outside of the microcontroller, maybe on board, but not inside the microcontroller. Also, there are certain microcontrollers which are inbuilt HSM. Also, you see there are different communication methods. We have secrecy on this onboard communication. So onboard in the sense these all units are present in single board, or not single board, I would say single vehicle, not outside the vehicle. So these are the secured onboard communication method that has been followed for the connections between sensors or peripheral electronic control units to the main electronic control units and then central gateways. And when you see the connectivity gateway, where this has a connection to the cloud, is when used defined as the off-board communication, because there is no direct physical connection between this cloud and this telematics unit, which is connected to gateway. There is a wireless communication, like using internet, kind of online connectivity. And coming to the smart charging is also an outboard communication, because we have this connectivity port in a car, but of course we connect this with the power grid or charging system, which is again an external connectivity unit. That's why we define this as the off-board communication. This is not in vehicle. Of course, we have port available, but the charging is coming from the environment, external charges. And coming to smartphone, tablet, laptop, they are just defined as a user devices that are connected to the gateway using different medias like Bluetooth or Wi-Fi or USB cable. And if you see telematics, connectivity, gateway, they all together connected using might be an Ethernet communication or external communication. So where the other units are connected to the external world. So that's why they defined we need firewalls in between these devices to protect the data which is being transceived. So this is overall vehicle architecture, I would say, contains several properties of cybersecurity that we use and we use during the development of the vehicle or a single ECU or a single component. Coming to next slide. Here's a small example that I would like to show with an existing architecture. So there is a key fob is trying to connect to the car and trying to unlock or lock the doors. And during this time, we have several issues already being connected in a vehicle and are powered on and getting communicated. And during this time, if somebody is trying to send some malicious information from key fob, of course, the connectivity module inside has internal connections to other issues like infotainment or OBD or telematics, where the non-malicious inputs are getting processed to the system from the each unit, and which are real foreign codes or malicious activities is being really rejected by the each unit by using cybersecurity algorithms what has been involved in terms of software or hardware, or etc. I hope you understand the basic essence of cybersecurity in automotive industry with respect to the process, techniques, and infrastructure what has been used for achieving cybersecurity in a product development of automotive industry. And I really appreciate if you really have some questions or comments, please do comment under this video, and it will be really helpful for me to understand your queries and address them and sort out your doubts as soon as possible. And at the end, I would say knowledge is more reachable when you really like this video, share this video, and subscribe to my channel. Stay connected with future of automotive industry. Thank you. Bye.